Hello everyone, welcome to Homework Help. If you find the video useful, please subscribe to the channel. In this video, we'll solve a vector algebra problem. As per the problem, if vector A, vector B, vector C and vector D are position vectors of points A, B, C and D respectively, such that vector A minus vector D dot vector B minus vector C equals vector B minus vector D dot vector C minus vector A equals 0. Then D is, we are given 4 answer choices. We have to choose the correct answer choice. Let's start by analyzing the given information. We are given the position vectors for 4 points A, B, C and D. All 4 given answer choices are about triangle ABC. That means we have to analyze a triangle formed by points A, B and C. Let's start by drawing the triangle. The 4 given answer choices are for orthocenter, incenter, centroid and circumcenter. As you may know, these points lie inside a triangle, so we can assume that point D lies inside triangle ABC. Let's assume point D is here. We have to use the given dot product vector equation to find the answer. Let's start by analyzing the given equation. We are given that vector A minus vector D dot vector B minus vector C is equal to the dot product of vector B minus vector D and vector C minus vector A, and their dot product is equal to 0. Since we are given that vectors A, B, C and D are position vectors for the 4 points, we should analyze the subtraction of these position vectors in terms of the diagram I drew on the board. Let's start with vector A minus vector D. Since these are position vectors, as per the diagram I drew on the board, vector A minus vector D is equal to the vector for line segment DA. Because as you may know, a vector can be broken up into its position vectors. So vector DA can be written as vector OA minus vector OD, which will be equal to vector A, the position vector for point A, minus vector D, the position vector for point D. We can do the same analysis for other vector subtractions. So vector B minus vector C represents the vector for side CB in the triangle. So we get vector CB. Similarly, vector B minus vector D represents the vector for line segment DB in the triangle. And vector C minus vector A represents the vector for side AC in the triangle. Now we can do the substitution. For the subtraction of the position vectors, we should replace them with the vectors from the triangle. So I get vector dA dot vector CB equals vector dB dot vector AC is equal to 0. This means the dot product of vectors dA and CB is equal to 0, and dot product of vectors dB and AC is equal to 0. This means that vectors dA and CB are perpendicular to each other. That's why their dot product is equal to 0. We can draw vector dA in our triangle. Vector CB represents the base of this triangle. So if vector dA is perpendicular to the base of the triangle, that means vector dA is part of the altitude of the triangle from vertex A to side CB. Because as you may know, altitude of a triangle is perpendicular to the side that it touches. As per the second dot product equation, vector dB is perpendicular to vector AC. We can draw vector dB. Vector AC represents side AC in the triangle. Since the dot product is equal to 0, that means vector dB is perpendicular to side AC. That means vector dB is part of the altitude from vertex B to opposite side AC. Vectors dA and dB have common point D. That means at point D, the altitudes of the triangle cross each other. Therefore, point D represents the orthocenter of the triangle ABC because orthocenter is a point where the altitudes of a triangle cross each other. That means point D represents the orthocenter of triangle ABC. So the answer should be option A. This should be the final answer for this problem. So these are the steps you have to keep in mind to solve this problem. I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.